Hey everyone, welcome back to another Ash Instructs tutorial. Today we're going to be focusing on, once again, chemistry. However, the topic today is classifying chemical equations, okay? So there is 4 or 5, so 1, 2, 3, 4, 5. Okay, yeah, 5 ways that we can classify these reactions, okay? So there is synthesis, which is where there are two different elements and then they combine to make a compound. There's decomposition, where the compound becomes two different elements, so they decompose. Single displacement, where there's a compound and an element, and that element substitutes one of the elements in the compound, which sounds a little bit complicated, but we'll get into it, and then it will be explained in the video. Double displacement, where they switch both sides of the compounds, and there is combustion. Okay. So let's go with the first example over here. So as you can see, there is copper and chloride and zinc. So in this example, zinc substitutes copper, which creates zinc chloride, and then copper is left by itself as a single element, okay? So once again, copper or zinc substitutes copper, so they switch places, and now it's zinc, chloride, and copper. So in this case, it would be a single displacement because one element is taking over or substituting that element in that compound, resulting in a single displacement, which is SD. Okay, moving on to number 2, magnesium and oxygen. As you can see, these two separate elements combine to make a compound, which results in synthesis, which is S. Aluminum fluoride plus bromine. As you can see, bromine substitutes fluorine in this case, and so instead of it being aluminum fluoride, it's aluminum bromide, and fluorine is left by itself, so that would be, once again, like number 1, single displacement. Okay, lead nitrate plus potassium iodide. Well, as you can see in this example, potassium and iodide stay the same. Potassium iodide and nitrate switch positions, resulting in lead iodide instead of lead nitrate, and potassium nitrate instead of potassium iodide. So these two switch, as you can see. So that's a double displacement. Double displacement. Nickel sulfide and results in nickel plus sulfur. So as you can see, as I explained before, one compound decomposes and becomes two different separate elements, which is obviously decomposing. I just gave it away over there. Decomposition. Okay, decomposition resulting in D. Nickel plus bromine result in nickel bromide. Simple example of synthesis. Sodium sulfide plus barium hydroxide is sodium hydroxide plus barium sulfide. Double displacement, as you can see, because sulfide and hydroxide switch places. Okay, tin iodide is becoming tin iodine, which is obviously synthesis. Sorry, decomposition, right? Which is because this compound is now becoming two different separate elements, so it's decomposing, therefore resulting in decomposition. So D. Methane CH4 plus oxygen is left with carbon dioxide plus water plus energy. As you can see, it quite gives it away, like it's the odd one out. So with method of elimination or process of elimination, we can classify this as combustion. So methane CH4 plus oxygen results in carbon dioxide plus water plus energy. So this is complete combustion, as there is carbon dioxide is created plus water plus energy. So that's complete combustion. So that would be a combustion. Okay. K plus HOH results in KOH plus H2. So as you can see, this potassium substitutes this hydrogen over here. So it's KOH instead of HOH, and then this hydrogen is taken away with just hydrogen gas. So that's left with single displacement. So SD. Okay. NiI2. So if I zoom in a bit here for you guys to see that better, if I can zoom in, okay, that's much bigger. Okay, so NiI2 plus F2 is equal to NiF2 plus I2. As you can see, F2 substitutes I2, so that results in single displacement. Okay. All right, HGO results in Hg plus O2. As you can see, it decomposes into two different separate elements, so therefore it is double displacement. Okay, double displacement. All right, so Ba plus Cl2 results in BaCl2. So as you can see, these two compounds result in one, or these two elements result in one compound. Therefore, it is synthesis. Alrighty. H2S plus LiOH results in LiS plus HOH. As you can see, it's a very clear example of double displacement, as this Li now transfers, or the Li and H2 now substitute, or they switch each other. So Li goes over here, creating Li2S, and then H2 comes over here, creating an HOH. All right, so double displacement. COBr2 plus PbNO32 result in PbBr2 plus CONO3. Okay, so these two switch, right? So CO and Pb switch, therefore resulting in, once again, double displacement. Ba plus Pr equals BaP2, so that's a clear example of synthesis. C2H8 plus O2 equals CO2 plus H2O plus energy. So once again, that would be carbon monoxide plus H2O plus energy, which is not carbon monoxide, carbon dioxide. My apologies. Carbon monoxide would be CO. So this results in, obviously, combustion. Okay, my C is a little bit weird there. Okay, combustion. And the last one, Cu plus AgNO3 is CuNO3 plus Ag. So these two guys get switched over, therefore resulting in a single displacement. So that is it for today's video, everyone. As you can see, I just simply described or went over some examples and classifying on how to classify reactions. So I hope this video found you well, and I will see you in my next video where we will tackle new obstacles and learn new things. All right, bye-bye.